Good day, everybody. How are you all doing? Today, we are going to talk about measures of center of a data set. So, here I'm going to share my screen with you. So, give me a minute. So, measures of center. So, we are talking about data sets for which we are going to measure center. So we are going to talk about compute the mean of our data set, compute the median of our data set, compare the properties of mean and median, find the mode of our data set, approximate the mean with group data, and compute a weighted mean. So the first thing we are going to talk about mean. So what does mean mean? The mean of a data set is a measure of center. If we imagine each data value to be a weight, then the mean is the point at which the data set balances. So we have five numbers: 68, 78, 83, 85, and 92. These are like weights placed on a number line. Now, if we put a fulcrum at 81.2, the scale will balance. That means it will not go down on the right because there are three numbers on the right of the mean. It will not go down if we put the fulcrum at 81.2 because of the heavy three weights on the right hand side of the mean, or it will not go up because there are only two numbers on the left of the mean. So if we put the fulcrum at the mean at 81.2 for these five numbers, the scale will just be balanced and lay horizontal. Recall that the population consists of an entire collection of individuals about which information is sought, and a sample consists of a smaller group drawn from the population. So sample is a subset or part of a population. We work with a sample because population is too large for us to reach conveniently. The method for calculating the mean is same for both samples and population. However, the notation is different. Always for population, we indicate the characteristics by Greek symbol. So sample mean is represented by English alphabets, such as X with the horizontal line at the top is X bar, that is the sample mean, where population mean is represented by that Greek symbol, which is small m in Greek language called mu. Okay, so population characteristics are always Greek symbols, sample characteristics are English alphabets. So how do we calculate the mean? As you know, the mean is the arithmetic average, so we have to add up all the numbers and divide by the number of numbers. How do we add all the numbers? Of course, we add all the numbers, but how is it represented algebraically? That is by that symbol, which is like an inverted or side by side capital M. Actually, it is capital S in Greek language called sigma. Sigma or Greek capital S means summation or adding up sum of all the numbers. So the sample mean is given by X bar, which is sum of all the numbers in the sample data set divided by n small sample size or n small n, which is the sample size. And the population mean is given by the Greek symbol m or mu, which is equal to, again, sum of all the numbers. Here we are dividing by the population size, which is represented by capital N. So the calculations are the same for the sample mean or the population mean. During a semester, a student took five exams. The population of exam scores. Why it is a population score only five number? Because there are only five exams during the entire semester. So this is a population consisting of five exam scores. So again, we add up all the five numbers, divide by five to get the mean. 81.2. Notice 81.2 is not a number in the original data set. Note that the mean is rounded to one more decimal place than the original data. This is generally considered good practice. It is often impossible to compute a population mean because we don't know all the values in the population. Instead, we draw a sample and use the sample mean as an estimate. That is, X bar, which is a sample mean, is often used to estimate the population mean mu. Sample means usually either overestimate or underestimate the population mean. So here is an example. There were 440 players in the National Basketball Association during a recent season. The population mean height was mu equal to 79.2. So they measured the height of each of the 440 players, added the 440 heights and divided it in inches, divided it by 440, sum of the 440 heights divided by 440 gave us a population a mean number of 79.2 inches. Now let's take two samples of size 5. So the first sample one, the 5 numbers are 81, 73, 82, 84, and 81 on the left. The sample mean in this case came out as 80.2, which is slightly higher than 79.2. So we overestimated. If we were to use a sample mean as a guess for the population mean, we are overestimating the population mean by 1 inches. On the other hand, sample 2 on the right taken from the same population give us a sample mean of 78.0. If we use that sample mean to estimate the population mean, we will underestimate the actual population mean by 1.2. The first sample, 80.2, overestimates the population mean of 79.2, while the second sample mean 78 underestimates it. These two samples were small, the samples of size 5. Means of larger samples tend to be closer to population mean than those of smaller samples. In statistics, we talk about a minimum sample of size equal to 30. The larger the sample, the more likely it is that the sample mean is closer to the population mean. Some people believe that the mean represents a typical data value. In fact, the mean may be a value that could not possibly appear in the data set. The mean of the 5 exam scores during the semester comes out at 81.2. Notice all the original scores are whole numbers, whereas the mean has a one place of decimal, which is 81.2. If, like most exams, the scores are always whole numbers, then 81.2 is certainly not a typical data value. Okay. Now we are going to calculate another characteristic of the sample, which is the median. What is the median? It's the center of the data. The median is another measure of center. The median is a number that splits the ordered data set in half so that the half the data values are less than the median and half of the data values are greater than the median. The procedure for computing the median differs depending on whether the number of observations in the data set is even or odd. If the numbers are arranged from the lowest to the highest, and if for the first example, sample size is 7, then the number in the middle, which is the fourth number arranged from lowest to the highest, is the median. However, if the sample size is even, as in the second example where the sample size is 8, then the median is the average of the middle two numbers. Okay. So there is a difference in how we calculate the middle depending on the sample size. If the sample size is odd, then it is a number in the middle. If the sample size is even, then the median is the average. That is, you add the middle two numbers and divide by 2 to get the median. Okay. During a semester, student took 5 exams. The population of exam scores is 78, 83, 92, 68, and 85. So you arrange the numbers from lowest to highest. First is 68, next is 78, then is 83, then is 85 and 92. The number in the middle is 83. Notice the median is the 50th percentile. What does it mean? Notice 50% of the data are below the mean, that is 68 and 78, and 50% of the numbers are above the median, which are 85 and 92. Hence, the median is the 50th percentile. It is the point where the data set is exactly divided into two equal parts. A set of numbers is higher than the median, another set of numbers is lower than the median. Okay, 8 patients undergo a new surgical procedure and the number of days spent in recovery for each is as follows. Find the median number of days in recovery. So we will do it in the calculator. The first thing we will do using TI-84 is to clear the memories of the calculator. So we will press the second button on the top left, then the plus button on top of enter, then number 4, which is clear all list, and hit enter. Done. Okay. So second button, then on the top left, then the plus button on the bottom right on top of enter, then number 4, which is clear all list on the calculator screen. So second plus and 4 is clear all list. Hit enter. Done. The memories are calculated. Now we are ready to enter the data in the order they have come in the problem. So how do I do that? I press the stat button, which is in the second row of TI-84, then number 1, and I type in the numbers 20, 15, 12, 27, 13, 19, 13, and then 21. So all these numbers are in L1 of my calculator. 20, 15, 12, 27, 13, 19, 13, and then 21. So there are 8 points, 1, 2, 3, 4, 5, 6, 7, 8. I want to find the median. How do I do that? After entering the data in list 1, L1, I press the stat button and then highlight. Highlight means move the cursor or the black rectangle on the top line from edit to calc, which is the middle one, in the first row. And then select number 1, which is one where stats. My first line list is always L1 where I've entered the data. And I go down to calculate, bring the cursor down on calculate and hit enter. And I do not see the median. I see the mean as 17.5. I have to scroll down, one screen down with the down arrow key on the top right. Down arrow key. The next line is the median. MED stands for median, 17. What does it mean? It means 50% of the numbers are below 17, like 12, 13, 13, 15, and 50% above 17, 19, 20, 21, and 27. Okay. So they show you how to do it by the calculator in these slides, which I'll skip. Compare the properties of the mean and the median. Both the mean and median are frequently used as measures of center. One important difference is that the mean is more influenced by extreme values than the median. A statistic is resistant if its value is not affected much by extreme values, large or small, in the data set. The median is resistant. What does it mean? Median's value is not influenced by extreme values in the data set more than the mean. Okay. So median is not influenced by the presence of very large numbers or very small numbers, whereas the mean is influenced by the presence of very small numbers or very large numbers, as we will see. So here is an example. 5 families have annual incomes of 25,000, 31,000, 34,000, 44,000, and 56,000. One family whose income is 25,000, that is the lowest salary, wins $1 million lottery. So their income increases to 1,025,000. Okay. Look at what are the mean and the median before they win the lottery. The mean is 38,000 of the first five numbers, 25,000, 31,000, 34,000, 44,000, and 56,000. The mean is 38,000 and the median is 34,000. Now, the family with the lowest salary wins a lottery. Their salary now become 1,025,000. Look at the mean. It shifts from 38,000 to 238,000. Difference of 200,000 in the mean value. Whereas the median shifts only from 34 to 44,000. Difference of 10,000 only. The mean is increased by 200,000. Median is changed only by 10,000. The extreme value of 1,025,000 influences the mean quite a lot, increasing it from 38,000 to 238,000. In comparison, the median has been influenced much less, increasing from 34,000 to 44,000. That is, the median is resistant. The mean and median measure the center of a data set in different ways. When data set is symmetric, notice this is a bell-shaped frequency distribution or histogram. On the vertical axis, you have the relative frequency. On the horizontal axis, in the top graph, you have the numbers divided into groups. This is bell-shaped. How did you get the smooth bell-shaped curve? You join the top groups of the vertical histogram, vertical rectangles. Okay, because it is bell-shaped, the left half is equal to the right half. It's symmetric. Symmetric means left half from the center. Imagine a vertical line in the center where the peak is the highest. The left half is equal to the right half. Symmetric. Okay, the mean and median are equal. In the right skewed second diagram, there are too many data points on the right. So the mean is pulled towards them. Mean is greater than the median. In this third, the extreme bottom diagram, it's left skewed. There is an extended tail on the left-hand side. That means there are too many small numbers. In this case, the mean will be pulled towards the small numbers. Mean is left than the median. So if in a data set we calculate and find the mean is much greater than the median, then the data set is positively skewed or skewed to the right. And if the mean is less than the median, then the data set is skewed to the left or negatively skewed. Point to be noted. Which is a better measure of center? So people argue which is the better measure of center, mean or median. They have both advantages and disadvantages. Mean advantages takes every value into account. Disadvantages highly influenced by extreme values, not resistant. Median not much influenced by extreme values, but median depends only on the middle value of or two middle values. So it does not take into account all the values in the data set. However, median is not influenced by extreme values. Compute the mean and median of the following samples. So we will use our calculator. We will press the second button on the top left, then the plus button on the bottom right above the enter button, then number 4, which will put clear all list on the calculator, then hit enter. Done. I've cleared the memories of the calculator. Then I press the stat button and number 1. Stat button is in the second row, then number 1. L1, L2, these stands for list. So in L1, I'm going to enter this data set 69, then 17, then 75, then 96, then 74, then 80. Notice most of the numbers are in the 60s, 70s, 80s, 90s, whereas suddenly certain number, a small number is there, age 17. Wondering if that would have been 71, wrongfully reported as 17. Anyways, let's take a look. So after we have entered the data in L1, then we press the stat button of the calculator, highlight calc on the top row, then select number 1, which is one where stats. Stat button, calc button in the top row, highlight calc, then number 1, list is L1, and I calculate. So my mean comes out at 68.5 and median is 74.5. So median is greater than the mean. The mean is, as I said, 68.3. Mean is less than the median. Reason, mean is pulled towards that lower number, 17. Okay, so mean is less than the median. So this is skewed to the left because of the presence of that small number 17. Okay. Someone surveys the families of a certain town and report that the mean number of children in a family is 2.1. Someone else says that must be wrong because it is impossible for a family to have 2.1 children. Is this correct? No. The number 2.1 is fine because remember, mean is not a number that is measured. And mean number of 2.1 children is not necessarily wrong. In each case, decide whether you would expect the data set to be skewed to the right, skewed to the left, or approximately symmetric. Mean is 6, median is 4, mean is greater than the median, positively skewed or skewed to the right. Second one on the top, mean is 5, median is 7, mean is less than the median, skewed to the left or negative, yes, negatively skewed. Third one on the bottom left, mean is 8, median is 8.1. They're about the same, so it's approximately symmetric. Next one, mean is 4, median is 3.8. You can argue they're about very close. And I will say approximately symmetric. Following is the information about the 5 starting players on a college basketball team. Their heights in inches are 74, 76, 79, 80, and 82. Their uniform numbers are 15, 32, 4, 43, and 26. Will we obtain meaningful information by computing the mean of the median height? Yes. Yes, the mean and median height are meaningful because heights are measurements. Will we obtain meaningful information by computing the mean and median of uniform number? No, these are categories. Okay, mean and median numbers are not meaningful because these numbers are just labels and do not measure anything. Next is find the mode of a data set. Mode is a number that occurs the maximum number of times in a data set. A value that is sometimes classified as a measure of center is the mode. The mode of a data set is the value that appears most frequently. If two or more values are tied for the most frequent, they're all considered to be modes. If the values all have the same frequency, we say that the data has no mode. 10 students were asked how many siblings they had, brothers and sisters. The result arranged in order. 0, notice 1 appears 4 times, 2 appears 2 times, 3 appears 2 times, and 6. Of course, 1 is the mode because that appears 4 times. The mode is sometimes classified as a measure of center. However, this isn't really accurate. The mode can be the largest value in the dataset as is shown by the height of the bar. That bar indicates a number which appears the maximum number of times. Remember, on the vertical axis, we have frequency or count, how many times each number appears. Does mode here measure the center? No, because it's one of the highest numbers. So point to be noted, mode is not a good measure of the center of a data set. Means and medians can be computed only for quantitative data. So mean and median are for quantitative data. However, mode can be computed for qualitative data as well. Look at these cars. Okay, these are brands of cars. So we cannot calculate mean and median, but we can calculate the mode. We want to find out which category of car appears the maximum in this table, and that is Toyota. Toyota is the mode. Okay. Approximate the mean using group data. Sometimes we don't have access to the raw data in a data set, but we are given a frequency distribution. Remember, frequency distribution is nothing but groups and the frequency in each group. So we have to compute the midpoint of each class. Remember, computing the midpoint is lower class limit of the first class plus the lower class limit of the second class divided by 2 gives the midpoint of the first class. And repeat the process. Actually, each of the midpoints of the consecutive classes are separated by the class width, as you will see. Okay. So here is the data set. So what is the midpoint of the first class? It is not 0 plus 49 divided by 2. It is, however, the correct way to calculate the midpoint of the first class is 0 plus 50, which is 50 divided by 2, 25. What is the midpoint of the second class? It is 50 plus 100, which is 150, divided by 2, which is 75. So the midpoint of the first class is 25. The midpoint of the second class is 75. Notice the difference between 75 and 25 is 50. 75 minus 25 is 50, which is same as the class width in this case, because 50 minus 0 is 50 is the class width. Okay. So this is the table of midpoints versus frequency. Now we have to calculate the mean of this data set. Of course, we can use the formula to do it, but there is a better way to do it using TI-84, which I will demonstrate to you. As usual in any new problem, you first clear the memory of the calculator. So second button, then the plus button on top of enter, then number 4. Clear all list, then hit enter, done. Then stat button, then 1, edit, L1, L2. Always in this type of data, group data, the midpoints go in L1. So in L1 of my calculator, I will enter the midpoints. Notice all the midpoints are separated by 50, which is the class width, as in 50 minus 0, 50. So we will enter the midpoints in L1, 25, 75, 125, 175, 225, and 275, the midpoints in L1. Now I press the right cursor key after 275. After I have entered 275 in L1, press the right cursor key, which is on the top right of the calculator. And the cursor of the black rectangle moves to the top line in L2, list 2, where I will enter the frequency 10, 5, 13, 11, 7, and 4. Again, midpoints in L1, frequency in L2. Once I have entered this data in the calculator, then I press the stat button. Much like before, I highlight calc on the top row. And then much like before, I select number 1, which is 1 var stats. Var stands for one variable stat. So number 1 I click. First line is always L1. We do not have to do anything. Now remember, I have entered the frequency in L2. So I have to tell the second line that it is L2. So bring the cursor to the right of the colon in the second line and press the second button on the top left and then 2. Second and 2 will give in the second line L2. This way I tell the calculator that the frequency is in L2. Then I go to calculate, go down, bring the cursor on calculate and hit enter. And the first line is the mean. The mean is 137. Let's see what they got. Mean is 137. Also, if we look at the raw data, take a look at the raw data. Notice the class between 100 and 149 has the highest frequency, 13. And that's where the center of the data set or the mean is, which is 137, in between 100 and 149, as you would expect. So you do not use the formula. You can use the calculator TI-84 to calculate the weighted mean. Okay. So that's actually we calculated the mean of a grouped frequency data. We can do the same calculation for a weighted mean. How so? A weighted mean is a mean in which some numbers count more than the others. To compute a weighted mean, we assign a positive number called a weight to each number, such as we assign the weight W1 to X1, okay, W2 to X2, etc. to each number, with the numbers that count more getting larger weights. If X1 through Xn are data values and W1 through Wn are the weights, the weighted mean is given by W1 times X1 plus W2 plus times X2 plus W3 times X3, etc., up to Wn times Xn, assuming there are n weights and n numbers from X1 through Xn. N can be any value. Again, this is the formula for the weighted mean, but we will use the calculator as I will tell you. Last semester, Joe took 4 courses. He got an A in statistics, 5 credits, B in psychology, 4 credits, C in English, 3 credits, and A in music, 2 credits. And A is worth 4 quality points, B is worth 3 quality points, and C is worth 2 points. Compute Joe's GPA. Here you have to remember the weights are the credit hours. Like my statistics course is a 3 credit course. So its weight is 3. So those weights are the credits in this case, which will go in L2. But before that, first we will clear the memory of the calculator. Second, plus on top of enter, then number 4. Clear all this, done. Then stat 1. In L1, I'm going to put the grades he got. He got an A in statistics. A means 4 quality points. Okay. He got a B in psychology, which is 3 quality points. And then a C in English. C in is equal to 2 quality points. Okay. So line 3 in L1 is 3. 2. So first line in L1 is 4. 4 comes from getting an A in statistics. Getting an A in statistics. Second line in L1 is B in psychology, which is 3 quality points. So second line in L1 is 3. Third line in L1, C in English, C is worth 2. And then an A in a music, which is 4 quality points. So the quality points are in L1. Okay. So I enter the last number in L1 as 4 for music for getting an A. Then I go to the top line, the first line in L2, and put the weights, which are credit hours. Statistics is 5. Psychology is 4. So the first number in L2 is 5. Then the next number is 4. Remember, I'm putting the credit hours. Then 3 in line 3. And then 2 in the fourth line in L2. So I've got the quality points like A, B, C, etc. in L1, and L2 I have the corresponding credit hours 5, 4, 3, and 2. Okay. Now I press the stat button, highlight calc on the top row, then number 1. My list is L1, my frequency is L2. I calculate. And the weighted mean is 3.2857, which they have rounded to 3.29. That's how your GPA is calculated. So remember, it is your grade you get. A is 4, B is 3, C is 2, D is 1, and so forth. Each grade is multiplied by the credit hours in the course. Like statistics course, usually 3 credit hours. So we talked about mean, median, how to calculate mean and population mean, distinguish between mean and population mean and sample mean, how mean, sample means are used as estimates for population mean. Then we talked about median, which is the 50th percentile. Then we talked about how to distinguish a data, whether it's skewed to the left or skewed to the right, or whether it is approximately symmetric. Then we talked about mode, which is a number that appears the maximum number of times. Then we calculated the weighted mean for group data. We also calculated the weighted mean. So I'll stop here today. If you have any comment, please write me a comment. I appreciate that. I appreciate that. If you like this video, please give me a thumbs up. Again, I appreciate that. If you like this video, share with your friends, you and your friends. Please subscribe to my channel and let YouTube know that you would like to be notified every time I upload a new video, which I do almost every day. So you hit on the bell button, okay? Click on the bell button. And please do not forget to watch me tomorrow again. And please subscribe to my channel by hitting the red subscribe button on the bottom right corner, okay? And I'll see you tomorrow. Thanks for watching. Have a nice day. Take care. See you.